Good morning. Today we are going to see the problem on economic load dispatch problem solving using participation factor method that we have seen in the previous class. So to refresh, we'll go to the algorithm once. We'll recap the algorithm fast. Then we'll come to the problem so that you can solve this problem very easily. So coming to the algorithm, the last class, what we have seen, like base point and participation factor method. So if you see like load on the power system will not be same at all the time. It may increase or decrease. It will be not same. Okay, during the in the power generators in the operation, it might be changing. That is, sometimes it might be increasing, sometimes it might be decreasing. As the load changes, the economic dispatch problem has to be solved repeatedly by moving the generators from one economical optimal schedule to the another economical optimal schedule, so that you can meet out the demand. Okay, why we are doing this in the sense to meet out the demand. So the economic schedule obtained from the equal incremental cost is known as base point factor. Then the scheduler assumes. So in the load dispatch centers, the scheduler will be there. That scheduler only will be assumes the load change, and he investigates how much each generating unit must be moved to serve the new load. Okay, say for example, one particular generating station, it is generating some 1000 megawatt. Suddenly the load has been demand has been increased up to some say for example the total demand is 15,000 megawatt. It has been increased up to some 17,000 megawatt. 2,000 megawatt you need to increase. Suddenly the scheduler, what he has to do is he has to increase that load. He has to call that particular generating unit, and he will be telling to increase the load to some 500 megawatt, and he has to call the generating unit to increase some other 500, so that some 2000 megawatt is deficit. So he has to manage that 2000 megawatt. So he needs to intimate the least cost generator. He needs to intimate the least cost generator, so that it might the new load also will be satisfied, and the demand. New load is nothing but the demand. Okay, sudden increase in the load must be satisfied. Okay, so if you see the fuel cost function, what is the fuel cost function? Fi of PGI is equal to AI PGI square plus BI PGI plus CA. So what is lambda? How to find out lambda? That is we have to differentiate this fuel cost with respect to PGI and equate it to lambda. Okay, so while differentiation, you will be getting like 2AI PGI plus BI. That is nothing but lambda. That is nothing but Fi dash. Okay, so single time you are differentiating that particular fuel cost. Next, you are differentiating the fuel cost double time. That is d squared Fi divided by d PGI square. That is nothing but 2AI. So 2A, so this lambda also we are differentiating with respect to PGI. So del lambda divided by del PGI. So del P is nothing but change in the power. Okay, change in the power. Del lambda is nothing but change in the incremental cost. Change in the incremental cost. So del P is nothing but change in the power. Okay, so next. So if you see like general formulation, del PGI is equal to, so we need to find out del PGA. Okay, change in the power generation. So how to find out the change in the power generation is, so Fi double dash equal to del lambda divided by del PGA. So del PGA is equal to del lambda divided by Fi double dash. Okay, so this is the general formulation. That is del PGI is equal to del lambda divided by Fi double dash. So if it is I na, so you need to substitute. Say for example, from I to so number of generating units, I is equal to 1 to n. So 1 to n you need to substitute. So del PG1 is equal to del lambda divided by F1 double dash. Del PG2 is equal to del lambda divided by F2 double dash. Like that up to del PGN. Del PGN, what is del PGN? nothing but del lambda divided by Fn double dash. Okay, so if you see this characteristics, if you see the characteristics, that is relationship between this del lambda and del Pj. So this is the del lambda change in the sorry. This is the fuel cost. This is the fuel cost. If that is lambda. Okay, so the lambda, and if this axis we are taking the PI. Okay, power generation. So initially, so you already will know this characteristics with the change in the fuel cost. With the increase in the fuel cost, automatically the power generation also will be increased. That we have already seen this incremental fuel cost characteristics. So here, if you see, like the initial lambda is lambda naught. Okay, so to some extent, okay, so due to the sudden demand, we need to change the demand, and also we need to increase the power generation. Say, for example, initial power generation is PI naught. Okay, so we have to increase the power generation to certain extent. Say, for example, PI1, PI2, whatever it may be. Okay, so that is for notation. For easily understanding, you can take like PI dash also, or PI1. So we are increasing from PI naught to PI1. So some certain generation we have increased. So similarly, if you see like this lambda also will be increased to certain extent. So that is this is called change in the lambda. That is del lambda, change in lambda. Okay, so this is what said. Next, for the change in the demand. So how to calculate the change in the demand? So you know very well know like power balance equation. What is the power balance equation? That is whatever the power generation, that equals the demand. Okay, so demand is nothing but sum of the power generation. Okay, it might be of 3 generators or 10 generators, 30, 40, 50, up to n generators. How many generators that is being participated in that particular dispatch? It might be of n generators. So says that is del PD, that is change in the demand. Del PD is equal to change in the power generation 1 plus change in power generation 2 up to del PGN. Okay, change in the power generation of nth generating unit. So you have to add all these things. You very well know what is del PG1. Okay, from this equation, del PG1, you know, that is del lambda divided by F1 double dash. Next, again del lambda plus divided by F2 double dash up to del lambda divided by Fn double dash. We very well know this. Okay, so now we have to simplify this. So I'm taking this del lambda outside. So 1 divided by F1 double dash plus 1 divided by F2 double dash plus up to 1 divided by Fn double dash. So that we can generalize, and we can write like generalized format. So that is nothing but del lambda into summation I is equal to 1 to n, 1 divided by Fn, Fi. Okay, so I is equal to 1 to n. So Fi double dash. So this you have to remember. If you don't remember also, you can derive simply one step only. You can easily derive, and you can frame this. So that is del PD is equal to del lambda into summation I is equal to 1 to n, 1 divided by Fi double dash. Okay, so what is this is the participation factor. What is the participation factor of the each unit? Is that the rate of change of each unit's output with respect to the change in the total generation. Okay, the rate of change of each unit output. Each unit output is nothing but 1 divided by Fi double dash. Okay, with respect to change in the total generation. Change in the total generation is del PD. Okay, change in the each unit output is, that is del PGI. Okay, del PGI. Okay, change in rate of change of each unit output, that is del PGI, divided by with respect to the change in the total generation. What is the change in the total generation? Is nothing but change in the demand, that is del PD. Del PD is equal to del PG1 plus del PG2 up to del PGN. So this already we know. We derive that is del PGI. Del PGI is equal to del lambda divided by Fi double dash. Del PD is equal to del lambda into summation I is equal to 1 to n 1 divided by fi double dash. Okay, so further simplification you will get like this. That is 1 divided by fi double dash the whole divided by summation I is equal to 1 to n 1 divided by fi double dash. Okay, so this you need to remember. This is called the participation factor. Okay, then the new power generation is equal to pi base. Okay, new power generation I is equal to pi base I plus del pgi divided by del pd the whole into del pd. Okay, this is the formula for calculating the new power generation. Okay, pi base plus del pgi divided by the whole divided by del pd into del the whole into del pd. Okay, so now we'll go move to the problem. Take down this problem. Use participation factor method to calculate. Use participation factor method to calculate the dispatch. To calculate the load dispatch, the load is increased to 900 megawatt. The load is increased to 900 megawatt. So the demand is, I think, the same problem we have solved previously also. The total demand is 850 megawatt, but suddenly the demand is increased. That is, load is increased to 900 megawatt. So what is the fuel cost function? The fuel cost functions are given below. That is, F1 of P1 is equal to 561 plus 7.92 P1 plus 0.001562 P1 square. Next, the fuel cost function of generating unit 2, F2 of P2 is equal to 310 plus 7.85 P2 plus 0.00194 P2 square. Next, F3 of P3 is equal to 78 plus 7.97 P3 plus 0.00482 P3 square. P3 square. Okay, so now what we have to do is we have to solve this problem by using the previous technique, whatever the technique which is very convenient to you. Okay, so the very convenient method for solving economic load dispatches, okay, by using lambda iteration method, and also gradient method is there, participation factor method is there. Okay, some methods we have seen. So in that method, whichever the method is easy for you, that method you choose. But for solving this problem, I think lambda iteration method is a very apt method that you might be saving some time also. In that method, you can go for solving using that method. Okay, by seeing the problem, you can easily choose which method to choose. Okay, while solving the problem, you can easily know. So for this apt method is lambda iteration method. I think we solved this problem previously itself. Okay, we solved this problem, same problem previously itself for 850 megawatt. If you go to our previous videos, you might be seeing this. Then what is the answer? First of all, we have to find out the answer. What is the P1, P2, P3, so that further we can proceed in some time. Okay, so same problem, the like fuel cost function, that is 561 plus 7.92 P1 plus 0.001562 P1 square, and the fuel cost function 310 plus 7.85 P2 plus 0.00194 P2 square. Next, the fuel cost function 78 plus 7.97 P3 plus 0.00482 P3 square. The same problem we have solved. Next, this problem we have solved using some conventional method, like we found out lambda, and again from the lambda we found out P1, P2, P3, and next we checked for the demand. So in the lambda iteration method, I think simply, I think two steps are by using the first formula for lambda, that is PD plus summation I is equal to 1 to n bi divided by 2ai, the whole divided by summation I is equal to 1 to n 1 divided by 2ai. So if you solve that that thing directly, you will get lambda. Next, for calculating P1, P2, P3, that is also lambda minus bi divided by 2ai. So if you calculate like that, then I think in one or two steps you can find out the answer. So if you calculate, we solved the same problem using this method, but now for this problem, if in exam it is asked, don't solve this method. Why? Because it is time consuming. So only with the two steps you'll get the answer. Okay, by using lambda iteration method. Okay, what is the formula for PGI? So PGI is equal to lambda minus bi divided by 2a. So if you substitute, then you can find out what is lambda. I think already you found out lambda by using the same method. You take this problem as homework. Then you can easily find out like lambda is equal to 9.1482. If you solve with that lambda iteration method. Next, like a PG1, like lambda minus bi divided by 2a. So whatever the value you are getting, so if you substitute directly, you will get the P1 as 393.164. Next, P2 as 332.47 megawatt. Next, P3 as 121.36 megawatt. So what is the demand is being given? 850 megawatt. Same demand also for this problem, like the same problem what we have seen for participation factor method. So what is the total demand? 850 megawatt. So these are the three answers already we got. Yeah, same problem. Demand is, I think here I missed to note mention the demand. So you note down the total demand is 850 megawatt. The load is increased to 900 megawatt. So from 850 to 900 megawatt, the load is being increased. The fuel cost function. So by solving the problem, I think we already found out what is P1, P2, P3. Okay. So now we have to go to the problem. How to calculate the new values of power generation by using the formula. So the new values of power generation is being calculated by Pi new is equal to Pi base plus del PGI divided by del PD, the whole into del PD. This is the formula for calculating the new generation, new values of the generation, that is Pi new. So what is P new 1? P new 1 is equal to just to substitute I is equal to 1. So P1 base plus del PG1 divided by del PD, the whole into del PD. So already, so this P1 base we already know from the previous problem. Sorry, not previous problem. We have solved, no? Now we have solved. Okay, previously we solved, but now you have to solve. Okay, in exam, don't write like by solving using previous method. No, you have to solve. Then you have to find out the P1 base. I think 393 point something, some 08 megawatt like that we found out. Now this is the formulation, that is P new 1. So we have to find out this del PG1 divided by del PD. So del PG1 divided by del PD, you know the formula, like participation factor, del PG1, sorry, del PGI. What is the general formulation? Del PGI divided by del PD is equal to 1 divided by Fi double dash, the whole divided by summation I is equal to 1 to n 1 divided by F1, sorry, Fi double dash. Okay, Fi double dash. So here what we need to do is we need to calculate del PG1 divided by del PD. Del PG1 divided by del PD is equal to 1 divided by, so what is the formula? First you write the formula, del PGI. We already solved. Del PGI divided by del PD is equal to 1 divided by Fi double dash, the whole divided by summation I is equal to 1 to n 1 divided by Fi double dash. This is the formula, that is participation factor of each unit formula. So that by using that formula, by substituting I is equal to 1, okay, I is equal to 1. So here del PG 1 divided by del PD. So 1 divided by F1 double dash, the whole divided by 1 divided by F1 double dash plus 1 divided by F2 double dash plus 1 divided by F3 double dash. Okay, so we need to find out what is F1 double dash. F1 double dash, how to find out F1 double dash? Okay, so you need to from the previous equation, we need to find out the F1 double dash. Okay, so F1 double dash, we need to differentiate. See, you need to differentiate. Fi double dash means you need to differentiate this. We already differentiated. Or otherwise, better you do one thing. Don't solve by lambda iteration method. Solve using whatever the method we solved in the previous problem. Okay, why? Because the differentiation and all easily we can get. Otherwise, or otherwise also nothing. Differentiation means only you need to differentiate this. Then you need to substitute that value, that is P1 is equal to what is the value, like 393 we have seen, no? What is the, yeah, 393, what is that value? Yeah, 393.08 something, the value you got. So the same megawatt you need to substitute here for Fi double dash. Okay, whatever the value of like P1, we have to substitute, differentiate and substitute P1 is equal to 393, and you will get one answer, that is as 0.003124. That you got now. I hope everybody is solving the problem with your calculator, scientific calculator. Okay, so if you solve this, you will get F1 double dash as 0.003124. Next, similarly, solve for F2 double dash. What do you need to do? We need to differentiate this equation with respect to P2, and we need to substitute P2 as some value, that is whatever the value you considered. Like what is the P2 base? Yeah, some 332 2.47 megawatt. By substituting 332.47 megawatt, you will be getting the value as F1 F2 double dash as 0.00. Sorry, this is double differentiation, no? So no need to substitute. So here double differentiation means 2 times you will need to differentiate. So you will get the value, this value automatically you will get this value into 2. Okay, into 2 this value. But you need to check this this notation, that is P1 squared or P1 like. So you need to double times you need to differentiation. I thought like this single differentiation. So this is double differentiation. So simply like double differentiation, you can easily get this answer. Okay, so this double differentiation you need to substitute over here. Okay, so what is del PG1 divided by del PD? So that is nothing but 1 divided by 0.003124, the whole divided by 1 divided by 0.003124 plus 1 divided by 0.00388 plus 1 divided by 0.00964. Okay, so further simplification, you'll get 0.47. That is del PG1 divided by del PD. That is 0.47. So how to calculate P1 new? So P1 new is equal to P1 base plus del PG divided by del PD, the whole into del PD. Okay, del PG1 divided by del PD, the whole into del PD. So what is P1 base? Already we have calculated. Already we have calculated by the lambda iteration method. I hope you solved. Okay, so this is P1 base. You are getting 393.08 megawatt plus this already we have calculated, that is 0.47 into this value del PD. What is the change in the power demand? That is power demand is 850. Okay, so now we have to go to the problem. What is the power demand? PD is 850 megawatt. The load is increased to 900 megawatt. So that is what is the difference? How it is increased? Like 50 megawatt. So del PD is 50 megawatt. Okay, that you need to substitute over here, 50 megawatt. Okay, so P1 new is equal to 416 megawatt. Okay, right? P1 new is equal to 416 megawatt. Similarly, you have to solve for P2 new and P3 new. So what is the formula for P2 new? Same. P2 new is equal to P2 base plus del Pg2 divided by del Pd, the whole into del Pd. Okay. So again, you need to calculate this del Pg2 divided by del Pd. So del Pg2 divided by del Pd is nothing but 1 divided by F2 double dash, the whole divided by 1 divided by F1 double dash up to F1 double dash. So here N is 3. So 1 divided by F2 double dash plus 1 divided by F3 double dash. So whatever the values you need to substitute, okay, substitute, and you need to find out the answer. So while substitute the answer, this values and further simplification, I think you got 0.3781. Okay, that is del PD2, del PG2 divided by del PD. You got 0.378 after decimal 4 digits for all the problems after decimal 4 digits. But whatever the given in the problem, that you need to take as it is. But for while solving, while simplification, substituting and solving, in that time only you need to go for after decimal 4 digits. So here don't round off. Here we calculated whatever they calculated, directly you add. So if you round off here, whatever the value we got, and if you round off here, then you will get huge difference in the generation. Okay. So here del Pg2 divided by del Pd2 already we calculated. So now we have to calculate Pg2 new. So Pg2 new is equal to this base value plus del Pg2 divided by del Pd into the whole into del Pd. Okay, the whole into del Pd. So this value we already got 0.3781 into the 50. Change in the demand is 50. So now we can get Pg2, that is P2 new is equal to 351. Further simplification, 351.377 megawatt. Okay, I hope the same answer you are also getting. Next, what is the P3 new? P3 new is equal to, yeah, P3 base plus P3 new is equal to P3 base plus del Pg3 divided by del Pd, the whole into del Pd. So same like that, we need to calculate this by similarly we have solved, no? Same like that, 1 divided by F3 double dash, the whole divided by 1 divided by F1 double dash plus 1 divided by F2 double dash plus 1 divided by F3 double dash. This is common. So further simplification, substituting and further simplification, you'll get the answer as 0.1521. So next P3 new. P3 new, what we got, like one, from the lambda iteration method, we got this value, that is P3 new is equal to this old base value. Okay, old base value, that is 121.36 megawatt we got. Okay, so plus this value, that is del Pg3 divided by del Pd into change in demand, that is del Pd, that is 50. Okay, so if you substitute and further simplification, you'll get 128.96 megawatt. Okay, this is the new power generation value. That is, so next at last you need to write this 3 generation values, like P1 new, P2 new, and P3 new, and you need to check whether it is satisfying the that is change in demand, that is 900 megawatt hour. So if you check now, it will come around like 899.9 and some values, that is approximately, you need to write, that is approximately equal to 900 megawatt. So you need to conclude, that is Pg1, that is P1 new, P2 new, and P3 new, that is power generation new values satisfying the demand, satisfies the total power demand. Like that, you need to conclude this problem. Thank you.